we saw that none of MTech students are active, and there exists an MTech student who is active is false, they are equivalent. We will formally prove that now, but if you look at the statement, it's clear. None of the MTech students are active, and which means you take any student who is not active during problem session. This says there exists an MTech student who is active is false, so they are equivalent. We will say that this math notation is also equivalent now. So to prove this, first thing is we need to convert this into proportional logic. Convert to proportional logic. Because the well-known implications or equivalences which we have discussed, they are all in the context of proportional logic. Fine, so I need to convert this predicate logic into a proportional logic before I employ a specific rule. And proportional logic is only a special case of predicate logic, right? So it is possible. So to perform this, what we do, so please note, when I say Rama is active during problem session. So this Rama refers to a specific element in the universe of discourse. But when we say some is active during problem session, then this could mean some x. We don't know which x we are referring to. Which is why quantifier plays a role when you bring some, all, and so on. But when you instantiate meaning when you look at the statement with respect to a specific element, then you see that it becomes a proposition. There is no quantifier. There is no existential quantifier. There is no universal quantifier. Rama is active during the problem session. So which means the statement is in the context with respect to a specific element. That element is Rama. Now you can say this is a simple proposition. You can represent this using P. But when you have some, all that, then you ask there exists X, P of X. And when the context is all are active, then we say for all X, P of X. So this is telling you something. What is that? If a predicate is instantiated with a specific element from UOD, it becomes a proposition. So when you say some is active, it is predicate logic. When that X refers to Rama, it becomes a proposition. Okay. Of course, you can also refer this as proposition, but we observed that we want to increase the power of proposition, which is why we brought in predicate. Now we are moving from predicate to proposition by instantiating the predicate with respect to a specific element. Okay. So towards this, we perform two things. One is called existential instantiation. This is if there exists appears. Another one is universal instantiation. This is for this variable, which means there exists x, p of x implies p of a for some a in UOD. This is called existential instantiation. Some are active. If that A is Rama, then Rama is active during problem session. So for all x, p of x becomes p of A for any A in UOD. When this happens? When you have universal instantiation. So you see that predicate logic, this is predicate. You see that predicate logic becomes a propositional logic on instantiation. It becomes a propositional logic on instantiation. And most importantly, you have to pay attention to this. Over here, A could mean any A because it is universal quantifier. Over here, it means some A because it means it comes from existential quantifier. Now that we have converted this into a proportional logic, employ the proportional rules and start simplifying it. Let's employ these steps for this. So for all x, mtech of x implies there exists active of x. Just for my convenience, I'll rewrite this as p of x implies negation q of x, which means p refers to mtech of the property mtech and q refers to the property being active. Now this being universal quantifier, employ this. When you perform universal instantiation, it becomes p of a implies their negation q of a for any a. Okay. This is what we have. Now I need to simplify this and arrive at this expression. Only then these two are equivalent. Note that we know P imply Q is equivalent to writing negation P or Q. This we have proved it is a tautology. Refer our earlier lecture videos or the scribe. Which means this can be replaced with this. So this becomes negation. Please note this implies negation P. So in our case it is P of A or negation Q of A. Okay. Most importantly, here P is a proposition, Q is a proposition. For us, P of A is a proposition, Q of A is a proposition. Okay. Again, note, if you have negation P or negation Q, this is equivalent to writing negation of P and Q. This is also a tautology. Either refer the scribe or look at possible values for PQ and look at this biconditional. You see that it is true everywhere. Which means what? This can be rewritten as negation of P of A and Q of A. Fine? Okay. Now, having simplified this, now we want to bring it to this form. So which means I need to reverse my process. Reverse my process meaning from the instantiation we have arrived at, through instantiation we arrived at a proportional logic. Now I need to reverse this. So from proportional logic I should go back to predicate logic. Instead of working with specific element like A or Rama, I will have to generalize this so that I get back the predicate logic. So that brings existential generalization and universal generalization, which we shall see next. So now to establish the equivalences, there are two approaches. One is through generalization. The other approach is this. You can also simplify this, meaning on existential instantiation, this becomes what? Negation of P of A and Q of A. This is for sum A. Please note P refers to MTech and Q refers to active. So when you perform existential instantiation, we get this proposition followed by this proposition, and there is a negation that comes as it is. Now this is all we have. Now this is true for any A, as you can see here. So from this, since it is true for any A, any student, it is true, which means for sum also it is true. It is true for sum A. So this is expression 1, this is expression 2, which means this and this are one and the same. So by taking this expression, we have simplified and arrived at this. Because this is a proposition, I need to instantiate, only then I'll get a proposition so that these two can be compared. Now since 1 equals 2, the expression 1 equals 2, therefore these two are equivalent. Thus A equals B. Okay. So to prove this, what is that we have done? We have done instantiation so that you come back to the propositional world. Why? So that you can employ well-known tautologies to simplify the expression. And on simplification, we get this, and this is true for any A, which means it is also true for sum A. You say all students are good, which means some students are good, and so that's really what we have. Here instantiation should be done because this is in proportional world, so this has to be converted into proportional world, and you see that these two are one and the same. Therefore, this and this are equivalent. So I repeat, first I perform instantiation so that this predicate becomes a proposition. P of A implies negation Q of A for any A. We know that P implies Q is equivalent to negation P or Q. So this is rewritten as negation P of A or negation this. Again we know that negation P or negation Q, biconditional negation of P and Q, then employ that, you get this. Since it is true for any A, it is also true for some A. Now I need to compare that with this, so convert this into proposition and you see that these two are same, therefore they are equivalent. Fine. And this is one way of doing this. One can also do like this. We do something called existential generalization. You move from proposition to the predicate. What is that? You have P of A for some A. Then this implies that there exists X, P of X. On the similar line, we have something called universal generalization. We say P of A for any A. Then this becomes for all X, P of X. You have a proposition, say P of A, and it is true for any A. Then what is that you can imply? You can imply for all X, P of X. It is true for some A, then you can imply there exists X, P of X. Okay. Now I am going to use this rule. Look at this, and it is true for any A, and from that we concluded it is true for some A. Okay. Now we perform existential generalization. Okay. When you perform existential generalization, let's see what happens. And from this also one can perform, and then it becomes universal generalization. If you try generalizing this, it becomes universal generalization. If we try generalizing this statement, it becomes existential generalization. Let's see what happens on generalizing these statements. So on performing existential generalization, I am going for existential generalization because we want to arrive at this. What do we get? We get negation. Please note, we need to do it separately because the predicates are different. Of course, the variable is referring to the variable used in the context, it is same. So there exists X, Q of X. So this is generalized. Each must be generalized separately. This is generalized to there exists X, P of X. And this is generalized to there exists X, Q of X following this rule. Fine? Okay. Now you see that there exists X, P of X and there exists X, Q of X, and this is equivalent to writing there exists X, P of X and Q of X. This also we will prove. For the time being, assume that this and this are equivalent. In the next lecture we will prove this, that there exists X, P of X and there exists Q of X is precisely this. So now this and this are equivalent. Okay. Now that's precisely our B. So at this point in time, I perform existential generalization. We get this, and this one is equivalent to writing there exists X, P of X and Q of X. Therefore, we have this expression. So we have looked at this from two perspectives. One, you instantiate both and simplify and show it's one and the same. This is approach 1. Another one, you take the first expression, instantiate, simplify, and then do appropriate generalization according to what we need. Then on performing existential generalization, we get the expression in B, which means these two are equivalent. So the questions like this, the approach is this: convert predicate to proposition, use well-known implications, equivalences, simplify, and then go back to predicate world by employing generalization. And more on this, couple of more case studies we shall explore now.